Right, my amazing students, we are going to check my sound and just make sure my sound is okay. Oops, my sound is completely off, so hopefully that will be good. All right, so what we're doing is 6.3 and 6.4, which are a little bit more complicated, and I wanted to give you a good video of these. So we're going to go through them very detailed here. We have a system. Now, anytime we have a system of equations, that means we have two, sometimes more, but right now we're just dealing with two equations that we have to solve simultaneously, which means at the same time. And we're going to see that if there is a solution, these two lines are going to cross at some point, and that point where they cross is the solution. Okay, now notice it says, note that you can also answer no solution or infinitely many solutions. Okay, now we've talked about this in the Saxon book. When it's no solution, you have two, oops, that doesn't look very parallel, does it? You have two parallel lines when there is no solution. Two parallel lines. So this one would be no solution. They're never going to cross. Therefore, there's never a point that will solve both of the lines. If we have an infinitely many solution situation, that means that these two lines are actually the exact same line. So if they're same line, I hope you're going to be taking real good notes on this, because you're going to be using these notes to do 10 problems on your own. I'm going to go through these 10 problems in great detail, and then you're going to have 10 to do on your own. So we've got same line means infinitely many solutions. Infinitely many solutions means they are the same line. And no solution means that they are parallel lines. The only ones that have a solution are two lines that cross in one point. So now, how do we figure out this? First, it says graph the system and write its solution. So on this one, we're going to solve, most likely, by graphing. So let's go ahead and try to do that. There's several ways we can solve, and one of them is by graphing. Y equals 1/2 x plus 1. So let's look at this one. Remember, y equals mx plus b is our slope-intercept form of the line. And this first line is in this form. Y equals 1/2 x mx plus 1 plus b. So on the first line, so we'll just say line 1 is slope is 1/2, and the y-intercept is called the b term is 1. So let's graph that one first. So we're going to start where the y-intercept is 1, right here. And then from there, we're going to go up 1 over 2, up 1 over 2, up 1 over 2, and put a point. 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 Now I'll come back and draw a line through there shortly, because I'm pretty sure that my line is not going to be just real super straight. I'll do my best there. Okay, so down 1 over 2, so that's a point. Down 1 over 2, so that's a point. Okay, so here's my line. Okay? Now, this was line 1. Line 1. Now, let's look at line 2. Line 2 is not in slope-intercept form, but we could put it in slope-intercept form pretty easily. We could get the y by itself by adding 2x to both sides. So let's do that. Let's add 2x to the left, and let's add 2x to the right. Okay, so we're going to have on the second line y equals. These two are going to cancel. We're going to be left with the y equals, and then 2x plus 7. 2x plus 7. Okay, so now we have a 7y intercept right here. So let's go b equals 7, and slope is 2. This is line